Welcome back to revision on Chem 101, part 2. In this part 2, we shall be reviewing past question on 2022/2023. Okay, we start immediately because there's no time. Question number 1, it says, electrons can be defined as fundamental subatomic particles which have, now, they are trying to ask us about the mass of an electron. Now, one thing you must understand there is that electrons are also known as cathode rays. Electrons, which are also known as cathode rays, was discovered by J.J. Thomson. That's one information I want you to know, that electrons were discovered by J.J. Thomson using evacuated cathode tube. According to Thomson, electrons are negatively charged. J.J. Thomson also obtained the charge to mass ratio of an electron, that is charge to mass ratio E/m. He obtained it to be 1.7588 times 10 raised to power 11 coulomb per kg. He got mass to charge ratio of an atom to be that. It was Robert Millikan that determined the absolute value of charge on an electron to be. Millikan said that if this is charge to mass ratio, then Millikan got that this E, which is charge, is 1.062 times 10 raised to power minus 19 coulomb. It was Millikan that gave us this, but it was J.J. Thomson that gave us the charge to mass ratio. Now, if E is now this, then we have mass of an becomes making M. This over this produce this. So we are going to be having E over 1.7588 times 10 raised to power 11. And E is 1.02 times 10 raised to power minus 19 over 1.7588 times 10 raised to power 11. And this over this will produce 9.1 times 10 raised to power minus 31 kg. Now, this is the mass of an electron. This is the charge on an electron. And this is the charge to mass ratio of an electron. Now, what is the question asking us? It says, electron can be defined as fundamental subparticles, which has this coulomb and mass. So, the mass is 9.1. While the charge is 1.02, and you see that 1.0 times 10 to the power minus 19, that is option C, and the mass of 9.1 times 10 to the power minus 31. So option C becomes the answer to that. So please master that. Question number 2, it says, calculate number of gram in 1 mole of Na2CO3. Number of grams in 1 mole of that. Okay. Remember that we have already learned that amount is equals to mass over molar mass. Then the number of gram, which is under mass, will become amount times molar mass. We are talking about Na2CO3. We need to get its molar mass. Its molar mass will become 46 plus 12. 46 plus 12 plus 16 times 16 times 3 will already give me 48. 46 plus 12 plus 48, that will give me 106. So the molar mass of this is 106. So M becomes amount. They gave us amount of 1 mole times 106, and that will give me 106 gram. That will give me 106 gram. That is option B. That is option B. Question number 2. So we are going to have something like this. Mg and chlorine. So we have 1.3 2 gram here. We have 5.26 gram here. Molar mass of this is 24, while molar mass of this is given to us as 35.5. So this will give us 0.055, while this will give us 0.148. This is the smallest among it. And then we have this. So this divided by this will give me 1. While this divided by this will give us 2.691. So magnesium is 1, chlorine is, you don't approximate this to 3. You don't approximate this to 3. You need to multiply by some fraction to make it, so if you multiply by 1, it's to 1.1. Let's see by 1.1, 2.691 times 1.1, you get 2.9. 2.9. Okay, 2.691 times 1.2, you get 3.2. 3.2. So if I multiply by 1.2, I will have 1.2 here, and I will have 3.2. So I think this become Mg1, then Cl3. This becomes the empirical formula. That becomes the empirical formula. So this thing is in the ratio of 1:3. Ratio of 1:3. So ratio of 1:3 will give us option A. Ratio of 1:3. We go to question number 4. It said identify the false statement. Identify the false statement. Let's see. It says statement A, substance and matter means the same thing. B, matter always have weight. C, matter always have volume. D, CO2, CS2, and CaC2 are typical organic compounds. Okay, I want to elaborate on that option D, organic compound. Because I have it that my answer there is option D. It says, identify the false statement is D. Yes, because matter always have weight. We say matter is anything that... Okay, question number 4. It says, identify the false statement. Option A says, substance and matter means the same thing. That's true. Substance and matter means the same thing. Option B says, matter always have weight. Yes, we have all know that matter is anything that has weight and occupies space. Option C says, matter always have volume. Yes, have weight and occupy space. It means it has volume. Option D says CO2, CS2, and Ca2 are typical organic compounds. Wrong. Most of them there are not typical organic compounds. So because of that, we need to know what are organic compounds. Organic compounds are large class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen, or nitrogen. Carbon being linked most commonly to hydrogen, oxygen, or nitrogen. Now, some few carbon-containing compounds which are not classified or seen as organic compounds are: one is carbide, CaC2, carbide. It has carbon, but it's not referred to as organic compound. Another one is carbonate. Carbonate, sodium carbonate, example, is not seen like that. We have cyanide. All these are not seen as organic compound. Now, if you look at that option, question number 4, option D, you are going to see carbide there, CaC2, which is not a typical organic compound. So it makes that option what? Wrong. Go to question number 5. It says the product of mass over volume in liters is, now remember that I've earlier told us about this formula that amount is equals to CV, concentration times volume. So that concentration becomes amount in mole over V in liter. So amount in liter, we have mole per liter. If we have mole per liter, okay, let me just ask L, capital L. It's going to give us concentration. So let's see what that question 5 is saying. It's the product of moles of solute over volume, mole fraction, molar, normal, molar solution, absolute concentration. Yes, absolute concentration. Number 6, deflection of alpha particle by charged nucleus is used to confirm the existence of neutron is the answer. Option A, neutron. Let's see what we have to know about that. Remember that Ernest Rutherford was the first to predict the existence of uncharged particle in the atom. Then it was confirmed by James Chadwick. Then after that, in a nuclear reaction, James Chadwick, during a nuclear reaction experiment, confirmed what Rutherford predicted. Then, however, Rutherford, through his alpha scattering experiment, showed the position of the neutron in an atom. So, number 6 says, deflection of alpha particle by a charged nucleus is used to confirm the presence of neutron. Okay. Number 7, Rutherford's experiment is used to confirm the existence of Rutherford experiment is used to confirm just like number 6 and number 7 are almost the same. It's used to confirm the existence of option A, atoms, option B, molecules, option C, gas, option D, positively charged nucleus, yes, which you call the proton. Okay. Number 8, alkali earth metals are alkali earth metals. Now, one thing you must know about alkali earth metal is that alkali earth metals occupy group 2A. They occupy group 2A in the periodic table. Alkali earth metal, they occupy group 2A of the periodic table. An example of them, we have beryllium, we have magnesium, we have calcium, we have strontium, we have barium, we have radium. Okay. Now, if you watch that observation of the options, you see that option D is most fitted because in question number 8, option A, lithium, it says the alkali metals are lithium. No, there is no lithium there. Option A is over. Magnesium, there is magnesium, yes, and it says magnesium and Fr, no. CS and Ba, no. Be, Mg and Sr, Be, Mg and Sr, yes. Group 2A, okay. Number 9, the halogens are, you say option A, inert gas, transition element, D, block element, E, group 7B. Yes, halogens are also referred to as group 7B in the periodic table. Let's see something about that. Halogens occupy group 7B of the periodic table. They include, this halogen we are talking about, they include fluorine, they include chlorine, they include bromine, they include iodine, they include astatine, astatine, and they include tennessine, TS. These are halogens. They are also called group 7B elements because they are found in the group 7B. Okay. Number 10. The diagonal position in the second and the third period are diagonal position in the second and the third period. Okay. A diagonal relationship is said to exist between adjacent elements in the second and in the third period of the periodic table. Okay. Let's see pairs. These pairs are pairs of diagonal, the ones that we have diagonal relationship with another one. We have lithium having diagonal relationship with magnesium. We have beryllium having diagonal relationship with aluminium. We have boron having diagonal relationship with silicon. So when you come to periodic table, lithium has diagonal relationship with magnesium, beryllium has diagonal relationship with aluminium, boron has diagonal relationship with silicon. So if you watch that, option C becomes the most appropriate answer there. Option C becomes the most appropriate answer there. That is for question number 10. Question number 11. The general feature in group and period of elements can be expressed as thus. The general features in groups and period of elements can be expressed as thus. Option A, the number of group correspond with the valency of element in it. Let us check PSG electron. If they have the same elements in the same period, will have the same number of shell. Let's see. Number of group correspond to the valence of electron. Yes, elements in the same group will have the same number of valence electrons. Okay, option B. The first number of a group of elements differ in certain respect from the same group number and later have same. No. Option C. Electropositivity character decreases from left to right but increases passing down the group. No. Option D. The smaller a cation, the more the anion is polarized by it. No, none of the above. So we go for option A. Option A for question number 11. Okay, question number 12 now. And inert gas are, remember that inert gas are these gases that cannot react. They have a completely filled orbital. Okay, let's see some of them. We say inert gases are gases which do not undergo chemical reaction under a set of given conditions. Example of them, we have helium, we have neon, we have argon, we have krypton, we have xenon, we have radon, and so on. These are inert gases. So that gives us correct option to be option B. That gives correct option to be option B. Question number 13 says, catalytic power is ability of an ion to accelerate a chemical reaction. Yes, because the question was that catalytic power are the ions. Catalytic power are the ions that are able to act as a catalyst. Not able to act as a catalyst reaction, no. They undergo oxidation, no. They do not lose or gain, no. Oxidation state do not change, no. Option A becomes the correct answer, which says ability to act as a what? Catalyst. Question number 14. Inner transition elements are also called inner transition element. Remember, this was discussed in part 1 of this. We have that the inner transition element, I gave you what they are also called there. So the option that we go for that is option A, which is the lanthanide and the actinide. Okay. Question 15. We have it that elements with electronic configuration as this has unpaired electron. Okay, let's see that. Look at that electronic configuration for question number 15. We have 1s2, 2s2, 2p4. If we are to draw it at 1s2, 2s2, 2p4. This one is completely filled. This one is completely filled. This one has 4. 1, 2, 3, then 4. It has 2 unpaired electrons. 2 unpaired electrons. So element with configuration, okay, has unpaired electrons. 2, option C. 2 unpaired electrons. Question number 15. 2 unpaired electrons. Number 16 says the first ionization energy is always smaller than the 16. Now listen. The second ionization energy is always higher than the first ionization energy because after removing one element from the outermost shell of a neutral atom, the nucleus attracts the remaining electrons with great force. When you remove one, the remaining one, they will guide it so well. So that's why the second ionization energy is always higher. For you to remove another one, you need a very high energy. So question number 16 now says the first ionization energy is always smaller than the what? Second one, because the second one is always higher than the first one. Question number 17. Isotopes are dictated by isotopes are we want to talk about things that we use to dictate isotopes. Isotopes are dictated by mass spectrometer. We use mass spectrometer. Use mass spectrometer. Number 18, which of the following is true about alpha decay? Which of the following is true about alpha decay? It says mass number decreases by 4. Remember that alpha decay will have something like this. Mass number decreases by 4. Let's see that. Atomic number decreases by 2. Okay. Mass number does not change. So we have option A to be I and II. Mass number decreased by 4 and the atomic number decreased by 2. Very, very correct. 19. Which of the following statements are correct about nuclear fission? Which of the following statements are correct about nuclear fission? Now, you must first of all know what nuclear fission is. We say nuclear fission is a reaction in which the nucleus of an atom splits into 2 or more smaller nuclei. The fission process often produces gamma photons and release a very large amount of energy. Produce gamma photon and release a very large amount of energy. Okay, let's go back to the question. It says, which of the following statements are correct about nuclear fission? The number of neutrons released exceeds the number of neutron released exceeds the number that causes the fission. Okay, we don't know that. II says new nuclei are formed, certainly. III, energy is produced, certainly. IV, smaller nuclei mesh to form large one, fission. Fission, no. So you see that option C, 1, that the number of neutron released exceeds the number of that causes the fission. II, which is saying new nuclei are formed, then III, energy is produced. Okay, you know, 2 and 3 are the most correct. New nuclei are formed when it fission. New nuclei are formed, energy is released. Then we said the option there will go with there is question number 19 is C. Remember, we said that nuclear fission is a reaction in which the nucleus of an atom splits into 2 or more smaller nuclei. The fission process often produces gamma photons and release a very large amount of energy. So it produces gamma photons and release a large amount of energy. So if you look at that question number 19 again, we have option A is any option that does not contain option I and III is wrong. So option A has II, and it has IV. IV says small nuclei merges to form no. Option A becomes wrong like that. Option B contains II but does not contain III, so it's wrong. Option D contains I contain III, but does not contain II. So we say option C becomes more correct. So that's question number 19. 20. Two radioactive elements, Q and S, have half-life of 10 hours and 20 hours. That means Q has 10 hours. Q, 10 hours. And S have 20 hours. They now asked us that, therefore, X decay faster than Q. No, now. Q will decay faster than X. Okay. Option B. Option B. Q emits fewer particles than S. It's not true. Option C. Q emits fewer particles than S. That's almost the same question. D is more than. The options there were not clearly written. So it's supposed to be S is more stable than Q. Then the S is missing there. If you watch now, S is more stable than Q. Very correct. It will take more time for S to disintegrate, but Q will disintegrate faster than S. Okay, that's question number 20. 21. When the nucleus of an atom emits beta particle, it is called beta decay. Beta decay. Okay, beta decay, option C. 22. Radioactivity was discovered by Becquerel. It was discovered by Henry Becquerel. Radioactivity was discovered by Henry Becquerel. Master that. 23. Types of radioactive radiation includes the following. Let us look at the types of radioactive radiations, which is question number 33. Let's write. There are 4 major types of radiations. We have the alpha radiation. We have the alpha radiation. We have the alpha radiation. We have the beta radiation. We have the neutrons, that is N. The neutron radiation. We have the electromagnetic wave radiation. Electromagnetic wave. We have the electromagnetic wave radiation. And inside this one, they have X-ray and gamma ray. They are all electromagnetic. Okay, these radiations, they differ in mass, energy, and how deeply they penetrate people and objects. So, going back to question number 23 now, we'll have more insight about it. Say types of radiation includes the following. There is alpha, yes. There is beta, yes. There is gamma, yes. There is nuclear reaction, no. You see, we have 1, 2, and 3, which is in option C. 1, 2, and 3, which is in option C. Question 24. The equipment used in dictating radiation includes the following, except, includes the following. Okay, there's no except there, includes the following. Let us see such equipment in, let's write. Some equipment used in dictating radiations are, 1, we have ginger molar dictator. Ginger molar dictator. Now, it can be used to dictate alpha, beta, and gamma radiation. Ginger molar dictator is used to dictate alpha, beta, and gamma radiation. Okay? But cannot dictate low energy of beta and gamma radiation. Ginger molar cannot dictate low energy of beta and gamma radiation. Number 2, scintillation dictator. Scintillation. They are capable of dictating low energy of beta and gamma radiation. So, scintillator dictator dictates the low energy of beta and gamma radiation, which the ginger molar cannot do. Okay? So these two are the two first. Then we have number 3. We have diffusion cloud chamber is also there. Diffusion cloud chamber. They can clearly show alpha particle tracks. They can clearly show the trace of alpha particle. Diffusion cloud chamber. So we have seen 3 of them, which is ginger molar. We have scintillation counter, and then we have diffusion cloud chamber. So if we are to look at option, they will say that option D should go for it. That's 24. Option D, ginger molar is correct. Scintillation counter is correct. Electromagnetic wave, no. Diffusion cloud chamber is correct. So I have I, and IV. I, and IV, which is option D. 25. The equipment used in the, okay, we have done that. 25, no, sorry. Rays with electromagnetic wave, but with shorter wavelength is, which one has the shortest wavelength? We will see that now. Let's see. Some electromagnetic radiation includes, you don't remember electromagnetic waves or radiation. They include radio wave, microwave, infrared ray, visible light, ultraviolet ray, okay, X-ray, gamma ray, we have said that, okay. Now note, radio wave have the longest wavelength. That's anywhere where you get, if you get radio, the wavelength is very long. Radio wave have the longest wavelength. Others have short wavelength. However, the shortest is the gamma ray. Gamma has a very short wavelength. So coming to that question number 25, it says rays with electromagnetic wave, but with shorter wavelength is gamma. And you get the shortest. Okay, 26. Dash can be stopped with a thin paper of aluminum foil. You know, this radiation, alpha, beta, gamma, and there are some things that they use in stopping them. Let's look at that. We have that alpha particle causes large amount of ionization. Yes, we have seen that. Then it can be stopped by a sheet of paper. It can be stopped by a sheet of paper. Now, beta particles travel several meters in air. Hence, it can be stopped by a thick plastic or 2 to 4 mm thick aluminum plate. A thick plastic of 1 centimeter or 2 to 4 mm thick aluminum plate. While X-ray have high penetrating power, just like I said in the gamma one. Then, alpha and beta particles travel several tens of hundreds of meters in the air. They can be shielded using thick plates or high density lead or iron. So let's see what the question 26 is saying there. So that can be stopped by a thin paper of aluminum foil. Aluminum foil. We read that in that is better is the answer. Option B. Option A, sorry, better. Because if you look at that, you will see that beta travels several meters in hence only can be stopped by plastic or thick aluminum plates. Okay. Okay, we move to question number. So we say it's option 26. Let's be very sure. Option B, beta ray. Option B, beta ray. Option B, 26. Option B, beta ray. 27. Which of the following rays has the highest ionization effects? Remember, we said that the highest ionization effect is for alpha. So we have beta ray, gamma ray, X-ray, and alpha ray. Alpha ray has the highest ionization effect. alpha that has the highest ionization effect. Question number 28. Question number 28 calls for calculation. So let's see to that. A radioactive substance have an half-life of 80 days. So we have that T half is equals to 80 days. They now say that if the initial number of atoms in a same sample is NO, initial number of atoms in a sample is 6 times 10 raised to power 10, how many atoms will remain? NT, we don't know how many atoms will remain at the end of 320 days. We have T, 320 days. Okay. Remember that we'll be using the formula that says that NT is equals to NO exponential minus lambda T. So you see NT, we are looking for NT. We have NO, we have T, but we don't have lambda. But you should know that T half is equals to 0.693 over lambda. Therefore, lambda becomes, you have T half already to be 80. So if I clean this now, I can write 80. So that my lambda becomes, if you calculate that, we have 80 lambda equals to this, so that we have 0.693 over 80. This will produce 8.6625 times 10 raised to power minus 3. Okay? So I haven't gotten the value of lambda now. I can solve because I'm looking for this. So NT there now will now become 6 times 10 raised to power 10 times exponential minus 8.662 times 10 raised to power minus 3. Okay, then times 320, and if you do that calculation well, you'll be getting 3.75 times 10 raised to power 9, and that is option A. So this is how to calculate half-life. This is the most important formula here. This is the number of atoms that will remain after a certain time. It's like this, after a certain time. This is the original amount that we were told. This is decay constant, which you can get from saying T half is equals to this over, then T is given. So whichever word they want you to do in half-life calculation must fall within this formula. So you can be able to pick out your own answer. Okay. So we'll go to question number 29. Go to question number 29. We have an alpha particle. Okay. It says that an alpha particle whose mass is 4 travel with a velocity of v is 20,000 kilometers per second. What is the kinetic energy? Kinetic energy, we know, is half mc squared. Okay, let's call this one C, so that we are going to be having half times 4. We are going to convert kilometer per second to meter per second, and that will be giving us 2 times 10 raised to power 7 meter per second. So we have 2 times 10 raised to power 7 meter per second. And if you do this very well, you'll be having 8 times 10 raised to power 14, which is option A. So that is for question number 29. We'll go to question number 30. Experiment with cathode ray tube have shown cathode ray tube by Rutherford. Experiment with cathode ray tube have shown A, that all nuclei contain protons. B, that all forms of matter contains electrons. C, that all positive rays are actually proton. D, none of the above. Now, cathode ray tube is also called the cathode ray experiment, and electrons are also called cathode rays. So it's talking about electrons. So that will make option B correct. Option B, that all forms of matter contains electrons. Question number 31. Question number 31. Isotopes of a given element differ in, I believe we know what isotope is, but I can remind us that isotopes have the same atomic number, and they are in this input. Okay, let's say isotopes have the same atomic number and position in the periodic table. Okay, but they differ in their mass number. So they have the same atomic number, but they differ in their mass number. Okay. Why did they differ in their mass number? Due to different number of neutrons in their nuclei. They have different number of neutrons in their nuclei. That's why they differ in their mass number. Now note, all isotopes of a given element have similar chemical properties. 1, they have different atomic masses. 2, and also they have different physical properties. Different physical properties, similar chemical properties, and they have different atomic masses. Now, with this knowledge, we go to question number 31. The isotopes of a given element differ in number of electrons they contain, the number of charge they have, the number of neutrons they contain, and they say all of the above. But we have seen from our listing that C can be correct. The number of neutrons they contain. Now, why? We say isotopes have the same atomic number and the same position in the periodic table, but they differ in their mass number. Why? Due to different number of neutrons. So that statement makes option C correct. Okay. Question number 32. It says the element chlorine exists in two isotopic form consisting of a mixture of 75.53% of chlorine 35 and 24.47% of chlorine 37. What is the atomic mass of chlorine? It's very simple to calculate. You calculate as I will do on the board. We have 75%, which is 75 over 100 times 35 plus 25 over 100 times 37. And if you do this well, you have 35.5 mil. Okay. So that is for that question number 32. So if you watch that question number 32, we have 75%, or you can say 76%, 75.53%. Okay, let me use, you see we'll still be having, okay, 75.5%. We have 75.5 divided by 100. 75.5 divided by 100, then times 35, because that is for chlorine 35, and that gives us 26.425. 26.425. What of this one? It is 24.47. 24.47 divided by 100, then times 37, and that gives us 9.0539. So if we add them together, we have 26.425, which will give me 35.4. This will give me 35.4789, approximately 35.5. So that's it. So what is the correct option there? The correct option there will be 35.45. This is option A. 36. Dash is a systematic arrangement of electrons in the atom, that is electronic configuration. And if you watch, it is not there. So question number 33, no option is the correct answer. 34. Ions or group of ions that have the same electronic configuration are said to be isoelectronic. Isoelectronic. Okay. 35. Which of the following increase down the group? Which of the following increases down the group? Let's look at that. Let's look at some statements. Electronegativity increases across the period and decreases down the group due to increase in atomic size. I take it again. Electronegativity increases across the group, across the period, and decreases down the group due to increase in atomic size. Atomic radius. Atomic radius increases down the group and decreases across the period. Atomic radius increases down the group and it increases down the group and decreases across the period. Increases down the group. Let me write it down because of benefit of doubt. Electronegativity. Electronegativity. You say increases across the period, increase. But does what now? Decreases down the group, decrease. I'll be using I and D. Increase, then decrease. We have atomic radius. That one say increase down the group and decreases across the period. Across the period decreases, but down the group increases. First ionization energy. Let me use it as Fi. First ionization energy generally increases across the period, due to increase in nuclear charge and decreases down the group. It decreases down the group. Why? Because outer electrons are further away from the nucleus and hence cannot be tightly bonded. We see that the option we are going to be looking at there is option C for question number 35. Which of the following increases down the group, increases down the group, increasing down the group? Are you seeing that? And increasing down the group question number 35, okay? Increases down the group, okay, is atomic radius. So question number 35 is settled, atomic radius. So option C, atomic radius. Option C. 36. Question number 36 now. It says, which of the following are not possible electronic configuration for an atom? That answer should be option D. Option D. That is III. Yes, because 2s cannot be, there must be 1s. Okay. III. We are talking about option D. IV. Okay. You see, watch IV. You see, 2p is carrying 8, which is wrong. Then we're talking about option D. V. If you observe that, 1s2, 2s2, 2p6, there should be 3s before 2d. Okay, that one is wrong. So we have mostly that 4 and 5 are wrong. So any option that does not contain IV and V is correct. So option A say I and II only. Which of the following are not possible electrons? So I and II, no. I is correct. I is correct. Okay. 1, 2. Okay. I. That can be for hydrogen. Okay. 2Si is wrong. 2Si is wrong. So IV and so option D is correct. 37. Elements in the same group have. We have not forgotten our PSG electron. Elements in the same group have the same number of electrons in the outermost shell, and that is option D for question number 37. The same number of shell. Elements in the same group have elements in way to question number 37. Elements in the same group have, okay, equal energy, no. Differ in number of outermost shell, no. Same number of valence electron, yes. That is option. Elements in the same group will have same number of electrons in the outermost shell, yes. That is question number 37. That's option C. 38. Which of the following correctly represent electronic configuration of magnesium 2 plus? Now, magnesium 2 plus. This 2 plus means that it's going to lose 2 electrons. So you are going to be having magnesium on its own. Its electronic configuration is 2, 8, 2. Then magnesium 2 plus will lose 1, will lose this 2. So it will be having only 2 and 8. So option A is the correct one. 38. Option A is the correct one. Eight, 9, 10, 11, 12. It will now become 10. If you count option A, you see that option A is correct. Okay. We have 39 now. Question number 39. Excuse me. We have question number 39. How many unpaired electrons are in 3p orbital of an atom of chlorine? Let's see. Atom of chlorine. Now this configuration for chlorine. So we have 1s, 2s, 2p, 3s, 3p. So we have this one is filled, this one is filled, completely filled. This one is filled, then 1, 2, 3, 4, 5. One unpaired. So question number 39. We saw 1 unpaired. How many unpaired electrons are there in 3p? 3p is 1 unpaired. Okay. 40. The energy required to remove the most loosely bonded electron from a gaseous atom is termed ionization energy. 40. 41. Elements in the same period have PSG electron. Elements in the same number of shell. So elements in the same period have the same number of shells. So we have 41 is A. 42. Which of the following statements is not true? Electronegativity increases across the period. Electronegativity increases across the period. That's true. Atomic radius of a positive ion is usually smaller than that of its parent. Yes, it's true. Yes, it's true. Atomic radius increases across the period. Atomic radius increases. We are talking about question number 42. Atomic radius increases across the period. Across the period, atomic radius will actually decrease. Okay. Atomic radius increases across the period. No, across the period, atomic radius decreases, but down the group, atomic radius will now increase. So the answer to that becomes option C. Option C. Atomic radius increases across the period. No, atomic radius decreases across the period. Okay, we go to question number 43. How many unpaired electrons are present in 2p orbitals of sodium atom? Question number 43. How many unpaired electrons are present in 2p orbital of sodium atom? 2p orbital of sodium atom. Sodium have atomic mass of 11. So if we are to check the unpaired electrons there, we are going to be doing something like this. 1s2, 2s2, 3p6, and 3s1. So I have 1s2, this 2s2, this is a 3p, 2p6, then 3s1. This one is filled completely filled. Then this one is half. So we have 1. Okay, the question, going back to the question again, question number 43. It says, how many unpaired electrons are present in the 2p? 2p? Oh, how many unpaired electrons are present in the 2p? Okay, please let's look at the unpaired electrons are present in the 2p orbital of a sodium ion. 0. P, there is no unpaired there. It is in the S that there is unpaired. So it's 0. Option B becomes the answer here. Option B becomes the answer here. There is 0 unpaired. Okay. Question 44. The occurrence of successive group of elements showing strong chemical similarities because of their similar enter electrons shell is called 44. I take that question number 44 again. Question number 44. The occurrence of successive group of elements showing strong chemical similarity because of their similar enter electrons shell is called, we're going to refer to that as periodicity. Yes, that's what we call it, is periodicity. Number 45, systematic arrangement of electrons in the atom of an element is called systematic arrangement of electrons. Systematic arrangement of electrons. Systematic arrangement of electrons in the atom of an element is called electronic configuration. Yes. 47, that's 45. We are into 46. Electrons of different atoms are held in discrete stationary energy level or orbits designated as KLMNO. We know that as 46 KLMNO. You know, you still remember? KLMNO. You still remember that? Okay. These ones are called the orbits. Why the SPDF are called the orbitals. That's 46. 47. Energy released when one extra electron is added to an atom from the negative ion is called option C should be correct there. Bond energy. Okay. Energy release when one extra electron is added. So ionization energy is taken. That's option A. Electron affinity to collect. Then bond energy should be correct answer. 48. Electrons enter into orbital of the lowest energy first until it is completely filled before electrons can be enter orbitals of higher energy. This statement is a statement of WU. 48. 6, which is Hofbann's principle. Hofbann's that you have to fill lower energy first before you go to the higher one. 49. The quantum mechanical description of a chemical bond formed by interaction of atomic orbit is a chemical bond, atomic orbital, molecular orbit. The quantum mechanical description of chemical bond formed by interaction of atomic orbits. I don't think there is correct option there. I don't. 49 has a little problem. 50. Ions or group of ions that have the same electronic configuration or structure are called isoelectronic. We have seen that before. 51. A reaction that takes place in the star and are responsible for generating new elements from hydrogen and helium is called option A, fission. Fission. Fission, not fusion. Fission. Fission, to break into, not to get to fuse. Fission, please mind it. Fission. 52. Way to 50. Ions or group of ions that have the same electronic configuration or structure is called isoelectronic. Then 51. The time it takes a given quantity of radioactivity to decay by half is called half-life. 51 is A, half-life. 52. The charge in mass on completion. The charge in mass on completion that takes place when nuclear reaction occur. The change in mass, the change in mass on completion that takes place when nuclear reaction occur is called mass defect. Remember, if nuclear reaction, you have the energy is equal to mc, delta mc square. Hope you understand. So we have mass defects there. Mass defects. That is 52. Mass defects. 52C. Mass defects. 53. A reaction that takes place in the star and are responsible for generating new elements. I will talk about that one. Fission. Fission. 53. 54. Hydrogen chloride gas was passed over 2.24 grams of heated ion in a hard test tube of compound was formed. What is the formula of the compound? Okay. Let's see that question. Just like the one we have solved it before. We are talking about iron and chlorine. We have 2.24 over 56. That is a molar mass of this. We have 2.84 over 35.5. Okay. Then we have 0.04. Then we have 0.08. We are dividing by the smallest. Here we have 0.04. Then we have 0.04 also. We have 1 and we have 2. So we have FeCl2. Now, this becomes the empirical formula. Since we are given that the molar mass of the empirical formula for the compound becomes this. So we have that the molar mass of the compound is 127. So we have FeCl2 into N equals to 127. So we have that to be this is 120. Then we have 127 N equals to 127. So that N becomes 127 over 127. N becomes 1. So FeCl2 into 1 will still give us FeCl2. So this is the formula for that compound, and that is option B. That is option B. 55. Iron reacts with H2SO4 according to this equation. Calculate the mass of iron that will be produced by 0.5 mole of iron. So I think that is a regular question we have been solving both in the part 1 and the part 2 in the place of stoichiometry. Look at the Fe plus H2SO4 produced FeSO4 and hydrogen. We are interested in this and we are interested in this. So if you watch there, we have that 56 grams of this produces 152 grams of this. So 28 grams of this will produce X. So that X becomes 28 times 152 over 56. And that will produce 76 grams. So if you watch that, there will not be correct option in that place. Remember that, go back to the questions and see. The question and say something. It says 55. Iron reacts with H2S according to this equation. Okay, now say calculate the mass of FeSO4. Calculate the mass of this that will be produced by 0.5 moles. So we are going to convert all the moles to gram so that you can calculate and leave your answer in mass, which is gram. So that is by the way. So we have 76 grams, which I'm not seeing in the option, except I'm making mistakes somewhere. 56. It said, what mass of aluminum oxide will be produced by 0.5 of aluminum reacting with iron oxide as shown in the equation below? Just the same thing as 55. So we are in 56 now. Just the same thing like 55. I'm going to clean this. So we have, that is 56B, Fe203 plus 2Al produce Al2O3 plus 2Fe. Now, we're interested in this and we're interested in this. 2 moles of Al produce 1 mole of aluminum oxide. So, converting to gram, this is 54 grams gave 102 grams. So that 13.5 grams will give X. X becomes 13.5 times 102 over 54. And that will give me 25.5. This is option C. I think we have seen something like this before. So if you look at question number 57, 56 has A and B. There's 2 questions tagged number 56. So it has A and B. This is the B, the other one is the A. Almost similar question. 57, incomplete. The question is not complete. Let's look at question number 58. An exponential process with a characteristic half-life is called, that's option B. That's option B. Radioactive decay. Yes, radioactive decay. 59. Dash relies on measuring the amount of carbon-14 in one living matter. Once in living matter. That is dash relies on measuring the amount of carbon-14, radioactive dating, radiocarbon dating, radioactivity. radiocarbon dating. I think radiocarbon dating should go for it. So that is called carbon dating. Hope you know. So we use the word, we go for the word dating. Number 60, that is a type of radiation. That's a type of radiation. That's for number 60. If you watch the nuclear reaction, it's a type of gamma. C, gamma is a type of radiation. Gamma is a type of radiation. Option C. So, so far so good. This brings us to the end of part 2 for Chem 101. And like I said before, this one we have gone through the questions and deliberate on it. You will now understand the particular topics that the lecturer is interested in, mostly periodic table, electron configuration, chemical bonding, stoichiometry, the simple part of it, and so on. So you look up all these things in your textbook again and equip yourself more with what we have done. I believe the exam will go well this time. Thank you so much and God bless us.